So in this video, before we actually begin, I wanted to give you just a little bit of a heads up. I am going to be talking about simplifying fractions. That should be a skill that you should be familiar with by now. However, if you are not, come find me. Talk to me, ask me a question. Right now, this video that you're about to watch assumes that you know how to simplify fractions. If you don't and you're not really sure, come ask me a question. Always ask your neighbor, okay? Like I said, it should be a skill you should know, but if you don't and you're confused, come find me and we'll simplify it. Now, let's get on with the rest of this video. In this video, we're going to be talking about what's called rational numbers. Rational numbers encompass a whole lot of different things, and several of these items you already know. So for instance, let's just go through our definitions and then we'll kind of explain what this box is about. There are what we call natural numbers. These are what you call your counting, okay? This is what you know. 1, 2, 3, 4, skip a few, 99, 100, okay? Those are counting numbers, just simply counting. 1, 2, 3, 4, 5, 6, 7. Those are natural numbers. It comes easy for us to count that way. Then there's what we call whole numbers. Well, whole number is simply this. It's all your counting numbers starting with 1, and then we also include the number 0. So whole numbers would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those are all whole numbers, all right? And then we have integers. Integers include your 0, your natural numbers, and their opposites. And we've already discussed this in previous videos. So that would be like -3, -2, -1, 0, 1, 2, 3, okay? Those are all integers. So you know all these. So when you look at this graph, we have natural numbers, which would be 1, 2, 3, 4. Whole numbers, which include all your natural numbers and the number 0. All right. And then integers, which include your natural numbers, your whole numbers, and then your numbers like your -1, -2, -50, and so forth, so on. All right, now we get to something called rational numbers. Well, rational numbers include all of these things that we just talked about, which you already know, but we also says this: any number that can be written as a ratio of two integers. Let's make that simple. It includes fractions, 1/4, or -1/4. It also includes decimals, such as 0.5 or -0.25. All right, so rational numbers include all of these things that you already know, but also includes fractions and decimals. All right, that's really all rational numbers are. It's just numbers that you know already, and then there's fractions and decimals. All of those are what we call rational numbers, okay? And they all fall within this box. Now, there's different types of rational numbers, which we already know: natural, whole, integers, basic, fractions. But then we go into a little bit something here. We have something that's called terminating decimals, all right? Terminating decimals are simply this: decimals, numbers that stops. Decimal numbers that stop. I should say stop. That's really bad grammar. So an example of that would literally be something like we wrote a while ago, 0.25. This is a decimal number and it stops at 0.25. Or we can write 1.3. It stops. It terminates. There's nothing after the 3. It's done. This is a terminating decimal. And we can do all these different numbers and examples. It's infinite. We can do a lot of different things. All right, so enough just to do it, 12.6892. This is a terminating decimal, all right? Now, repeating decimals are decimal numbers that have a repeating pattern, such as, this is a most common one, 0.33333333333333333333333333. I'm going off the desk, okay? And the number keeps repeating over and over and over again. This is a repeating decimal. Here is another example of a repeating decimal. Well, before I do that, we actually have a shorthand of writing this type of decimal, and it's 0.3 with a bar over it. This bar tells me that I'm repeating this number over and over again. So let's do another repeating decimal. 0.25252525252525 and all the way until infinity and beyond. This is a repeating decimal. It's repeating the same pattern over and over again. And the way we would write this one, shorthand, would be 0.25 with a bar over it. All right? Now, I'm going to take a little bit of a side note here, and I want to show you something. There is a huge difference between these two numbers. So the question that I'm going to ask you is this 0.3 less than, greater than, or equal to 0.3 infinity? All right? With a bar notation. So this, is it less than, greater than, or equal to? So take a moment, pause the video, and see what you think. What you should have figured out is that this number is actually less than 0.3 bar notation. And here's the reason why. I already wrote 0.3 infinity out right over here, and this one stops where this one doesn't. Okay? See the difference? 0.3, 0.3 with bar notation. This has got more to it. It's more than 0.3. It's 0.33333333333333333333333, where this one is just 0.3. This number is actually bigger, even though when you write it like this in shorthand, they look to be the same. All right, just be aware that this is bigger than that. Just something to feedback. All right, so let's go through some rules, because what we're about to do now is we're going to take a fraction and we're going to write it as a decimal. So it says this: if applicable, keep the integer. 2, divide the numerator by the denominator to view the decimal. Combine decimal and integer. All right, so we'll walk you through it in just a second, all right? But this is how we go from a fraction to a decimal. So let's just kind of look at the next page, okay? And just keep this in mind. So this first one is -9/10, all right? So what we are going to do is we're going to divide 9 by 10, all right? So let's just go ahead and set this up, all right? So I'm going to take -9 and I'm going to divide it by 10. So the first thing I have to ask myself is this: is my final answer going to be a positive or negative number? Well, if you remember our rules, when we take negatives and we divide it by a positive, if the signs are different, my final answer will be negative. So I'm just going to go ahead and write that out right now. I know it's going to be negative. And now I've got that. It's just a matter of writing this out like normal. Can 10 go into 9 evenly? No, it can't. So I can't do anything. So I'm going to have to put a 0 as a placeholder and a decimal. And in that case, what I have to do is I'm going to have to bring a 0 in here. Okay? Can 10 go into 90? Yes, it can. It can go into 90 9 times. So let's subtract. Now we already kind of moved that negative out there, so I'm going to just kind of forget about it, so we don't have to worry with it anymore. And then we're just going to subtract like we normally would in division. What's 90 minus 90? Nothing. So I have a remainder of 0. So I have divided 9 divided by -10, or vice versa, and I get that it's -0.9. All right? So it's just division. Now let's look at this next one, 2. It says -4 2/3. Now remember in that very first step it says keep, if applicable, keep the integer. I'm just going to write that integer, this number right here, by itself. I'm going to kind of keep it over here somewhere. I'm just going to write it, -4 by itself. And I'm going to concentrate just on the 2/3. All right, I'm going to keep the -4 and I'm going to write -2/3 by itself, and I'm going to divide. And I'm going to say 2 divided by 3. So let's do that. Okay? Can 3 go into 2? No, it cannot. All right, so I've got to put my placeholder in the decimal. So bring my little 0 in. Can 3 go into 20? Yes, it can. It can go in there 6 times. So 3 times 6 is 18. Subtract it out, and I get 2. Well, 3 can't go into 2, so I've got to do another 0 and bring down. And then I know that that's going to be 6 times. And I'm going to repeat 3 times 6 is 18. Subtract gives me 2. And then I'm going to repeat the same process. 3 cannot go into 2, but I have to bring another 0 down. Okay? And then I know 3 can go into 20 6 times, and it's going to give me a remainder of 2 again. And if you have figured it out already, this is going to be giving me 0.6666666666666 repeating over and over and over again. It's never going to stop. It's never going to go away. It's always going to be 0.6666666 to infinity. I'm too lazy to do any more work on this, so I know that I can rewrite this as 0.6 with a bar notation on it. That's where that last step says, take the integer and the decimal and combine them. So I took my integer, which was -4, and I took my decimal, which was 0.6 repeating, put them together. This, written as a decimal, is -4.6 with a bar over it. Why don't you try 1 by yourself? What you should have got was 1.4375. So the next piece of this is to change a terminating decimal into a fraction. That is what we're going to do. So the very first step is much the same as the last time. If applicable, keep the integer. Makes your life easier. And then this next step gets a little confusion, but we'll help you out. It says write the digits after the decimal point as the numerator. Write the last digit's place value as the denominator. Simplify the new fraction, and then combine the fraction into integer. In all truth and honesty, going from a terminating decimal to a fraction is a whole lot easier than going from a fraction to a decimal. It's just easier, and you'll see why in just a second. So, let's look at this first one. We have a -0.84. Well, I'm just going to go ahead and I already know that my final fraction is going to be a negative, so I'm just going to keep that in mind because of this negative right here. But let's look at the rules here. It says, if applicable, keep the integer. Well, the integer in this case is -0, so I'm just going to kind of write that over to the side, all right, just so I don't forget it. Step 2, write the 2 digits after the decimal as the numerator. So the digits after the decimal are 84. So I'm going to write that as a numerator, okay? And then it says to do the following. Write the last digits, the very last digits, place value as the denominator. So hopefully by this time you should understand place value. You should have learned this last year. This value here that I'm holding is the 1's place. This is the 10th spot. This is the 100th spot. So what I'm going to write is this as 84 over 100 because the last place value is 100. So I have a fraction. I just made it, 84 over 100. So my job now is to simplify this fraction. Well, there's a couple of ways that we can do it, but we'll simplify it one step at a time. What number can go into both 84 and 100 to simplify a fraction? More than likely, you thought of 2. So if we did that, we can say that we divide that all by 2 just to factor out of 2, and that becomes 42 over 50. Can I simplify this even more? Yes, we can. We can factor out another 2. In doing so, that becomes 21 over 25. Can we do anything else more with it? Can we simplify more? No, we cannot. Now, let's go back to it. So I have my integer, which was a -0, and I have this, which was 21/25, and we simply combine it. And since my number was a negative to begin with, my final fraction, I'm just going to rewrite it really big, is actually going to be -21 over 25. All right? So let me do this one with you. My whole number, my integer is 5. So I'm just going to kind of write that off to the side. Just going to write it off to the side so I don't forget it. Now, and then it says that I have 0.22. Well, this 0.22, that's my numerator, so I'm going to write that down. And that's my numerator. And the last place value of this was in my 100th position. So that's 22 over 100. So I've just created my mixed number, 5 and 22 over 100. Let's simplify this, and I know that 5 stays the same. I can factor out a 2 out of here and get 11 over 50. The next piece is here. I want to do the same thing. I'm going to keep my integer. I'm going to keep that, so I'm going to write -1. I'm going to take the decimals and write it as my numerator, so 716 over, and I need to look at my place value. This is my 10, this is my 100, this is my 1,000. So that's going to be over 1,000, okay? Now that we've done this, it's just a matter of simplifying. And I'm going to kind of just take the time. I want you to pause the video, and I want you to try to simplify this on your own. So what you should have got was -1 and 179 over 250. That's what it should have simplified for. All right. Now, the number 7, 8, and 9 is asking you to order the numbers from least to greatest. So the best thing for you to do is to try to get all of these to look like the exact same thing. The way I would do it personally would to be change all of our numbers into decimals. So first off, I have 1/5. So I'm going to divide 1 by 5. So I got to do a little bit of work over on the side. I know that 5 cannot go into 1, so I can put my place variable there, put my 0 here, and then I do know that 5 can go into 10 2 times. So 2 times 5 is 10. I subtract with a remainder of nothing. So 1/5 can be written as, I'm going to write it over here to the side, 0.2, so I can remember it. And then I have -1/2. Well, let's do some work. I know that my decimal is going to be a negative because my fraction's a negative. So let's find out what my actual decimal is. 1 divided by 2. 1 cannot go into 2, so I've got to put my 0 here in my place values, all back down. I do know that 2 can go into 10 5 times. So 2 times 5 is 10. I subtract with a remainder of 0. And my decimal is 0.5. So this -1/2 is 0.5. Now that I know what this decimal is and what this decimal is, I can compare and contrast all my numbers and write it in the correct order. So why don't you pause the video and try to do that now. So once you've got it all corrected, you should have gotten that -1/2 was the smallest number, followed by -0.25, followed by 0.1, followed by 1/5, followed by 0.3. Why don't you try 8 and 9 on your own? So for 8, you should have gotten -1.6, -6/5, -7/8, 0.9, and 5/2. Then for 9, you should have gotten -10/3, -1.3, -2/3, 0.5, and 5/9. All right, so what I'm going to do is I'm actually going to leave you with 10 and 11 as a challenge problem. So please try these on your own. You know the drill. You need something, you come find me, ask me questions, ask other questions. Always do that, and I'll see you in the next video. Bye-bye.